Welcome to our video on transparent bridges and how they learn to build their forwarding tables in extended LANs. We'll explore how bridges learn MAC addresses and populate their forwarding tables through frame transmissions. Let's start by looking at our network topology. We have 3 LANs connected by 2 bridges B1 and B2. There are 5 stations: S1 and S2 connected to LAN 1, S3 connected to LAN 2, and S4 and S5 connected to LAN 3. Initially, the forwarding tables in both bridges are empty. Let's see how bridges learn through frame transmissions. First, let's watch as S1 sends a frame to S5. Since the bridges don't know where S5 is yet, they will flood the frame to all ports except the one it came from. However, both bridges learn that S1 can be reached through the port where the frame entered. Next, S3 sends a frame to S2. The bridges flood this frame as well since they don't know S2's location. Both bridges learn that S3 is connected to LAN 2. When S4 sends a frame to S3, the bridges now know where S3 is, so B2 forwards the frame directly to LAN 2. The bridges learn that S4 is connected to LAN 3. After all frame transmissions, the bridges have learned the locations of all stations. Bridge B1 knows that S1 and S2 are on port 1, and S3 is on port 2. Bridge B2 knows that S3 is on port 1, and S4 and S5 are on port 2. This learning process allows the bridges to forward frames efficiently, only sending them through the necessary ports to reach their destinations. In conclusion, transparent bridges learn MAC addresses by examining the source address of each frame they receive. They use this information to build their forwarding tables, which helps them make efficient forwarding decisions. This automatic